Hi everyone, I'll try to make this quick. We're going to go over chapter 6, which are the chemical bonds, starting first with ionic bonding. So ionic bonding is just so chemical properties such as reactivity depend on the element's electron configuration, which we've talked about before. Ionic bonding, stable electron configuration. So again, think of how many valence electrons elements are trying to get. They're trying to get 8. So when the highest occupied energy level is filled with all these electrons, the atom or the element it's bonding to, that's going to be stable. It's not likely to react. So remember, 8 is great. So how does the number of valence electrons compare to the number of the group they belong to? They are just the same. And maybe I can put this into a slideshow. Give me a second here. Okay, this might work a little bit better now. So they are the same. So when we're looking at the stability of an atom, on whether it's stable or unstable, we look at how many electrons are in that outermost orbital. So if we're looking at an element like hydrogen here, it is unstable right now because the first orbital shell needs 2 electrons in order to be stable. So hydrogen is constantly looking for something to bond with. At group 1A, 1 valence electron. Group 7A also is looking for something to bond with. Remember how we said fluorine was the most reactive nonmetal? Fluorine is right below it, another very reactive nonmetal. So if you have hydrogen who has 1 electron, chlorine has 7. These are both unstable unless they bond together. And so we'll talk about that here in a little bit. So argon, which is a noble gas, that is in group 8A. It has 8 electrons. So this is a stable element right here. It's not going to react with anything else. Helium, another noble gas, it's stable because remember that first orbital shell only can have a maximum of 2 electrons. So it's going to be stable. The goal of all atoms is to become stable, just like the noble gases, which all have 8 valence electrons, except for helium, which we just looked at. So helium, that's stable. Neon, 1, 2, 3, 4, 5, 6, 7, 8, that's stable. Argon, same thing. There's 8 in the outer shell, it's stable. Sorry if you can't see that bottom part. It might be cut off here a little bit. There you go. You can see that. So elements that do not have a complete set of valence electrons tend to react. That's what we just talked about with groups 1A, 2A, 3A, and then groups 5A, 6A, and 7A. That was what we're going to look at more in this class. Because remember I talked about how group 4A, there's a whole class in college on just carbon and organic chemistry. We won't talk as much about that. So elements achieve stable electron configurations through the transfer of electrons. As I was talking about earlier with hydrogen and chlorine, sodium and chlorine also do this. So when an atom gains or loses electrons, the number of protons no longer equals electrons. The atom then can be called an ion because it is an overall negative or positive charge. So if you look at sodium, which is in group 1A, and chlorine, which is in group 7A, sodium is a positive oxidation number, chlorine is a negative oxidation number because this one loses electrons, this one gains electrons. As you can see, that's why they react together to become stable. So at these ionic bonds that losing electrons, the overall charge of an atom is going to be neutral. Like we've talked about before, atoms are neutral. Ions are going to have a charge to them. So with hydrogen, obviously we have 1 proton. If we have 1 proton, we need 1 electron. Stable, that's 0. Not stable, sorry. Moving on. So what happens if hydrogen loses an electron? It's going to become or have an oxidation number of +1. So now that hydrogen has a charge, it is not called an atom. It is called an ion. Very good. And if it's positive, remember it's a cation. Losing electrons. So if we look at calcium here, that has 20 protons. So if it has 20 protons, it's got to have 20 electrons, making it 0. But if it loses electrons, that outer shell, because it loses those 2 electrons, it's going to be positive 2. So that oxidation number is plus 2. Gaining electrons is just the opposite. So chlorine is going to gain an electron to get that 8 valence electrons. So right now it's 0, but to become an ion, gain that electron, it becomes a negative ion, also known as an anion. Oxygen, and I'm just going to run through these quickly. Same thing, 8 and 8, making it 0. That's an oxygen atom, that is. But if we want to gain an electron to make it a full outer orbital or outer shell, you have 8 protons and then 10 electrons. So that's going to be negative 2, or a negative ion, an anion for oxygen. So this is what I just talked to you guys about. Here's a funny comic that was on Mrs. Olson's notes. Thought you would enjoy it. Perhaps one of you gentlemen would mind telling me just what is outside that window that you find so attractive. And it's obviously having these atoms look for these other atoms to bond with. So looking at the properties of ionic compounds, high melting points, poor conductors of electricity, good conductors of electricity when melted, strong forces of attraction, and then compounds tend to be solids that are brittle. Sodium chloride, this is our table salt. 7, 1, they are going to make 8. It becomes stable. What about sodium? How does losing 1 electron make it stable? Well, let's look at it. Losing that electron, that means it's going to have 8 in its outermost orbital. Chlorine's gaining 1, that means it's going to have 8 in its outermost orbital. Sodium chloride, table salt. Chemical bond, the force that holds atoms or ions together as a unit. Ionic bond, the force that holds cations and anions together. So forms when electrons are transferred between a metal and a non-metal. It's very important to remember, ionic bonds are always between a metal and a non-metal. So ionization energy, I'm going to quickly go through this. As you can see, and again, I've put the material up on Google Classroom if you need to look at this again without me talking about it. So the amount of energy needed to remove an electron from an atom varies from element to element. Lower the energy, easier to remove an electron. Energies increase from left to right across a period. Energies decrease down a group. Chemical formula, notation that shows what elements a compound contains and the ratio of atoms or ions of these elements in the compound. So you have iron and oxygen here. Over here we have hydrogen and oxygen. Here's one, magnesium and chlorine. It's wanting to steal this electron to make it full. Now magnesium is what's going on here. So now if we have 2 chlorine atoms, it can take that other electron from magnesium. That means that all 3 of these are going to have to bond together. Magnesium chloride, I believe. Yes, magnesium chloride. Chemical formula, sodium chloride is NaCl, which tells you that there's 1 sodium and 1 chlorine. However, magnesium chloride has 2 chlorine atoms and 1 magnesium atom. So 6.3, naming and formula ions. Why name? So all scientists know exactly what each other is talking about. I'm going to quick go through this. Yeah, I'm not going to go through this today. You guys can look at this on the notes with naming and formulating, or the naming and the formulas, ions. But we do need to get to covalent bonding. So covalent bonding is a chemical bond in which two atoms share a pair of valence electrons. This is called a single bond. So when they share two pairs, it's a double bond. When they share three pairs, it's a triple bond. I'll show you what I mean by that in a little bit. So to represent a covalent bond, here is the electron dot diagram. Hydrogen has one little dot. Another hydrogen has another little dot. They can bond together to have that 2, because there's a maximum of 2 on that outermost orbital. This is a single bond. So to represent a double bond, you use 2 lines. A triple bond is going to be 3 lines. I know you can't, it looks like it got cut off a little bit there, but there should be 3 lines. Molecule, a neutral group of atoms that are joined together by one or more covalent bonds. The attractions between the shared electrons and the protons in each nucleus hold the atoms together. Diatomic molecules, the 2 in the chemical formula. Dihydrogen tells you there are 2 atoms in the molecule. And we've talked about that before. That's just with counting atoms. So this is a single bond between 2 hydrogen atoms. Now, oxygen needs 2. Remember, it's group 6A, so it needs 2 electrons. This is a double bond because it's using 2 electrons from each oxygen atom, signified by 2 lines. Now, nitrogen is in group 5A. It needs 3 electrons. So this electron will bond with this electron, this one with this one, this one with this one. So that is a triple bond. Polar covalent bonds, that means it's just unequal sharing of electrons. And what determines that? That's just the types of atoms, the shape of the atoms. We'll talk more about that later. Water, for instance, dihydrogen monoxide, H2O, attractions between polar molecules are stronger than nonpolar molecules. So again, the naming you can look at through on the back of your periodic table as well. Use Greek prefixes. Oh yeah, and this is what I was kind of getting at when I was talking about different formulas. So when you go talk to your teacher and you need a drink of water, instead of asking, may I get a drink of water, you can say, may I go get a drink of dihydrogen monoxide? Because that is the chemical formula or name for it, actual name. And that is really concluding our notes today. Feel free to look on Google Classroom if you'd like. Again, you guys have a quiz on Monday. So get ready for that. It's going to be on counting atoms, oxidation numbers, ionic and covalent bonds, as well as the dot diagrams. So your assignment today is to complete the ionic compounds versus covalent compounds sheet. That's a blue sheet. And also the dot diagram worksheet. When you finish it, you can bring it up to look at the key, but only when you finish it. I will give the key to Ms. Shaw. And other than that, email me if you have any questions. You are going to have to do a little bit of studying if you want to be successful on this quiz. So have a good Friday, good weekend. I'll be back on Tuesday.